So we're going to go over the chart so we get used to the functions that we have to start, okay? On the first question, they're asking us for zeros. Do you remember how to find zeros of the quadratic?
You just isolated?
Yeah, we isolate. Essentially, our q at x or our p at x are essentially y. Okay, so we can rearrange the equation so it is y is equal to x squared minus 4. Now, if you look at this one here is a difference of squares. Do you remember that type of factoring at all?
Yeah.
Do you know what you would do with this? Alright, so difference of squares means I can find the square root of the first and the last term, and because I can do that, we put it into our two brackets. Okay, we get we take our first term. Square root of x squared is x, so we use that as our first term. Square root of 4 is 2, and the only thing is one of these has to be negative and one has to be positive. Okay, so with that being the case, we've now factored it. Now they're asking for zeros, which means they're looking for either our x-intercepts or asymptotes. So we're going to set our y equal to 0 in this one. So we set y equal to 0, we get x minus 2, x plus 2. Does this ring a bell?
Yeah.
We split them. We set each of the brackets equal to x. And our two zeros in this equation are x at 2 and x at negative 2. Does that make sense?
Yeah.
Okay. So what they've done is, if you notice, this equation is essentially this equation here. It's the exact same thing. So instead of going through all of this, I'm just going to factor right away. Okay. So our q at x, 1 over x minus 2, x plus 2. Now, because it's divided by this number here, the number on the bottom can actually never be 0. It'd be an undefined equation. So that's where the graph never touches. So instead of x-intercepts, that's what these two are, these are going to be our asymptotes in this one. Okay? So we, again, same idea. We take the bottom. Now, because the bottom can never equal 0, so the bottom of this equation, put it in red. So these two here cannot equal 0. We just got to make sure it doesn't equal 0. So we're going to figure out what x cannot be in this instance. So same idea. We set it equal to 0. X plus 2, and lo and behold, x cannot be 2. Okay? And x cannot be negative 2. Okay? So x cannot be 2 or negative 2. Those are two asymptotes we found. Okay? So when we go to put them in here, zeros were at 2 and negative 2. That was zeros. And this one would be asymptotes. Okay, we're not spelled down. That's Y-M-P-T-O-E-S. Alright, 2 and negative 2. So we know this is a positive function. Okay, our a value here, our a is positive. And because it's squared, okay, so it's a quadratic function, when we go to put it in a graph, because it's positive, we know we're going to be actually going, so remember our quadrants, 1, 2, 3, and 4. These ring a bell? Okay. So because it's quadratic and it's a positive function, we know that we're going to be starting in quadrant 2, going down, and eventually hitting quadrant 1. Okay, so what this has told us is our two x-intercepts. So our two x-intercepts are going to be, we discovered, were negative 2 and 2, our x-intercepts. So we know at negative 2 and 2 are x-intercepts. So in other words, we know that this function is going to be positive until it hits negative 2. And then it's going to become positive again after negative 2. Or sorry, after positive 2. So anything before negative 2 and anything after negative 2, our y values are going to be positive in this function. Does that make sense?
Yeah.
Okay. What about, so we want to figure out what our original function is going to be like. So we're actually going to set up our coordinates here. And we're going to plug these values of x into our equation so we have coordinates, and we can kind of connect the dots to figure them out. So when our x value is negative 2, so f at x, or f is at negative 2, what's our function?
0.5.
Yeah, negative 0.5. Alright? Good. F at 0. What does that equal? We talked about it just before. I was trying to factor. Do you remember it all? No? go back to it again. What about when it's 1?
1.
Yeah.
2.5.
Yeah.
And
Or a third,
mhm.
right? Oops, that's not 3. Or a half, negative a half. What would negative 3 be?
Negative 1/3.
Yeah, so negative a third. Okay. So here are our coordinates. This is considered undefined because we can never divide by 0. If you put it into your calculator, you can get math error. Okay. So that means this is what our asymptote is going to be at. Okay.
Okay.
So let's try to make sense of this equation. Let's bring our graph in. So reciprocal functions. If we go by ones, we're going to kind of, it's going to be squished, hard to tell. So what I'm going to do is I'm actually going to go by, let's go by 0.5s. So this is going to be 1, -2, -1, -1. -3, -4, -5. Does that make sense?
Yep.
1. Okay. So our first corner we had was at -2 and -0.5. So we're at -2 and -0.5. So that's going to be right on to, let's do it in red so it's a little different. Okay. -2, -0.5. When x is -1, we get -1. Okay. So really we haven't got a lot of points here. This isn't too helpful. So usually what we're going to do is I'd plug more points in or I'd go in between. Now, do you have an idea of what this function is actually going to look like?
It's going to go like...
It's going to curve, right?
Yeah.
Yeah, we're going to be curving. So essentially our function, it's never actually going to hit our x-axis or our y-axis, okay?
Mm-hmm.
So it's going to keep going down like this forever. Then it's going to come from down here, and at 1 and 1, oops, so let's say that's here. It's going to touch at 1 and 1, and then it's going to come down again. And again, it's never going to hit our x-axis, our y-axis or our x-axis, okay? Mm-hmm. So a key point is that -1, -1, 1 and 1 is a normal one of these functions, okay? Now when we're going to transform them, we got to go back to remembering our old rules. Our old rules with our functions were, I can't remember what variables you guys used, but say this was f at x. I believe you had an a of the function k, was it? Is that what you used?
I think so.
And then x minus maybe b plus c. I think that's what your book uses. A, k, and c. And you remember these deal with vertical stretch, vertical transformation, horizontal stretch, horizontal transformation. Okay. So what we want to do is we want to look at how this would have affected our function. Okay. Now let's go back up here. So we have our graph all graphed out, and let's go back to what we were originally trying to solve. Okay. So we had our asymptotes. What was the question asking? All values of this function are positive. So we figured out when it was positive. We have to try to figure out when this function is going to be positive. Okay, so we know that this function originally starts quadrant 3, stays in quadrant 3, and then goes into quadrant 1 and stays in quadrant 1. Okay, so we've got to figure out what our two asymptotes were. We had two asymptotes we discovered, right? What were they?
It cannot equal to 2 or -2.
So that means we have this straight down there. +2 or -2.
So to find the asymptotes, you just find the zeros.
Find what our x values of 0 are. So x, and remember this would be a function of x cannot equal 2, right? So it can't equal 2 there, and it can't equal 2 at our other spot. So essentially we're going to get a function that's going to roughly do something like this, come down, And we know it's going to do something like this in the end. What is going to happen in between? Do you know?
Isn't it? It goes. There's another one in between.
Mm-hmm. What do you think? What is that arrow going to look like? Have you ever seen tangent function?
Mm-hmm.
Yeah. So our tangent function is going to look very similar to that. So what's important to figure out where it's going to be in between. Some of the functions will look like a tangent. You're right. Some will be parabolas. We're going to test it. I was just using tangent as an example. Here we are. We knew that one of the asymptotes was x was at -2, okay, and the other asymptote was that x was at +2. So we're going to test the numbers in between. Okay. Essentially, we could do just whole numbers, but that's only going to give us the options of 1, 0, and so -1, 0, and 1, right? We might want to test something like -1.5, -0.5, 0.5, +1.5. We might want to test those in our values of x. So let's go and figure out what exactly is going to happen in here. When we go to plug in, let's start with our whole numbers because they'll probably give us a decent idea. Squared minus 4, we end up with 1 over 1 subtract 4. What do we get? 1 over -3. So we're at 1, we're at -3. Right? Let's try the same thing with p at +1. What do you think is going to happen? Do you have any idea?
It'll be the same thing.
Yes, exactly. It's going to be the same thing. So what do you think we're leaning towards in the middle? Are we leaning towards a tangent function or are we leaning towards a quadratic function?
A tangent.
Okay, we're getting close. Let's try 0, 2.
It'll be undefined 0, right?
Well, let's see.
Wait, no, it'll be 1 over -4.
Ah, good. Right, so we're going to get 1, 0 squared minus 4. We're going to get 1 over -4. So let's get an idea. Let's try to plot those. So we're going to get rid of what we've drawn to be tangents so far and see what we're likely going to get. We had, when we were at 1, what were we at? -1/3?
Yeah.
+1 was -1/3. And 0 was
1/4.
-1/4. So it's even a little lower than that. Right? So let's try to get closer to our asymptotes because we know that in between it's doing something.
It's a smiley face.
Yeah, it's getting to a smiley face. Let's try our outer limits, okay? So -1, -1.5. So p at -1.5.
Is there a faster way of figuring out this, or you just look at
We're going to show you, but first I want to show you what the functions technically look like, okay? 1.5 squared minus 4, what's that give us?
-6.25.
So we get -1 over...
Oh, are you asking for negative or positive?
So it's going to be positive. 1.5, 1.5 is going to be what? 1 times...
Oh, shoot. Sorry.
That's okay. 1.5 squared. 2.25 minus 4. -1.75. So we get 1 divided by -1.75. We're getting decimals here. Let's figure out what that number is exactly going to be. 1 divided by 0.5. Okay, 0.57. So we're getting... So let's look at our numbers. This one was 0.25. This was, sorry, negative 0.33. Negative 0.33. What was this one? Negative 0.57.
Yeah.
And this one's going to be positive, or sorry, negative 0.57 also.
Yeah.
So let's look at our graph. negative 0.33, negative 0.33. It'd be better if we could zoom in.
Mm-hmm.
Actually, I think I can. Let's get right down there. Okay, so this makes a little more sense. Negative 0.33 is going to be roughly here.
Mm-hmm.
Negative 0.33 roughly here. Negative 0.25 is a little higher.
Yeah.
Are at 0.5. Around here, we're at point. You know what? Let's see if you can draw on these too low. It's because this marker's too thick. Oh well. 0.25. That's a quarter of a way. Third of the way. At half, we were at half of the way, right? Or even a little lower than that. And then, as we get even closer to the asymptote, it's going to complete that same idea. Yes. And what kind is it? Yeah, so we're flipped upside down. We have an inverted quadratic function. So let's zoom out here. So we're getting a function that's going down like that. Now, if we go look at our quadratic, we would know that it's going to be a quadratic in the middle and not a tangent function because we have a squared in there. So that's how we know we're going to. Okay, so. Okay, exactly. So we only have one asymptote. Yeah. Okay, so we know we're going to have a linear function. Is this going to be? This is going to be a reciprocal function, right? So we know we're going to have f at x is equal to something like this. Or it's going to be 1 over something, right? So we have asymptote. And we know that the x on the bottom is going to be just to the power of 1. Okay? What else do we know about this? What's the...
Like the asymptote is 2.5, so it would be this one. Not easy.
Yeah, real easy. So we got C. And they do 2.5 like that because you set the bottom equal to 0, right? So if we were to set the bottom of it 2x minus 5 equal to 0, bring the 5 over, 2x divided by 2 becomes 5 over 2 equals x. Or in other words, can't equal x, right? X cannot equal 2.5. Does that make sense?
Yep.
All right, great. Okay, so we have this function. Now we know the bottom part of this function can never equal 0, right?
Yeah.
Okay, so it can't equal 0. So let's assume we figure out what this number is, okay? Let's get rid of the x minus 2. If this number itself is negative 1, so if that becomes negative 1, whatever that is, we have a negative sign minus 1. What's that going to end up being? 1 minus 1. Yeah, 1 minus 1, which equals what? 0. Okay? But that's not exactly our x value. So we know that these brackets themselves can never actually equal the number 1. So x minus 2 squared can't equal 1. So let's try to figure this out. Well, if we square rooted this, okay, so we square root both sides, right, to get rid of this. What's square root of 1? Sorry, say it again.
0.5, right?
Square root of 1? No, 0 squared.
1.
Bring the 2 over. 3. So we end up at x. Wait, is that right?
Yeah, that's right. It's 3.
Yeah, x is 3. So according to this, sorry, we made a mistake here because this itself can't equal negative 1. Negative 1. Okay, so first thing, when I go to square, I would square root both sides, right?
Yeah.
Square root this, square root negative 1. What happens when I square root negative 1? Math error. You can't square root a negative.
Yeah.
In other words, we don't have one.
Yeah.
Okay? But we do know, where is it? So when we normally draw this function, negative 1 and 1 is our turning point. So we're constantly moving. We hit 1, and then boom, we come back up this way.
Yeah.
Okay? And same idea here, positive 1. We come through and over, and then we turn. Okay? So if you have a linear function, whatever your linear function is, like they had negative 8 there, came across. The x-intercept gave us our vertical asymptote. This gave us our vertical asymptote. And now what she wants here...
Wait, how did she know that it was negative 8?
because she found out in that question y equals a half x minus 4. We solve for when x, this is our x coordinate, our y, right?
Yeah.
When x is 0,
Yeah.
oh, sorry, when y is 0, when we're on this line,
Yeah.
what's our x value? So our x intercept. So in other words, we're looking for a coordinate that has, we're looking for our x value of it. We know the y value is 0. So we plug 0 in for y. So we get 0 is equal to a half x minus 4. We bring 4 over, we get 4 equals a half x. I'm going to bring a half over. It's 4 divided by a half, or in other words, it's 4 times 2.
Yeah.
Okay? Does that make sense to you? Okay.
Yeah.
So our x-intercept is at 8.
But it's -8.
Oh, sorry. When I brought... Oh, sorry, I wrote the question down wrong. That's positive 4. When it comes over, it becomes negative 4. Negative 4 times 2 is negative 8. Okay, so we have negative 8 and 0. That gives us our x-intercept for our red one, our linear equation, which is also our asymptote. And then, because all of our horizontal asymptotes right now are 0, we want to find 1 point above that and 1 point below that. So we set y equal to those. So instead of y being 0, when y is negative 1, yeah, for sure. Do it that way then. Plus 4, and when y is normal, just 1. That's how she finds the 2.